Hello, out there, it's Darasa Online again, and we'll be discussing advanced mathematics. And today's topic will be integration, and specifically in the subtopic known as the volume of solid of revolution. And you will be with Mr. Kimati. So please, welcome and be with me from the start of the session to the end of the session. Welcome. Now, we will cover the following. First of all, we shall try to define and see some sketches of something called solid of revolution. What is that? I will show you a short video that elaborates what we are going to talk about. And then after that, we shall try to derive or find some few derivations of the formulas that will be used for that. And then after that, we shall do some few examples to that. And then after that, I will leave you some few questions for you to practice. And as you know, these are not the only questions. We have a lot of questions. So please find more questions and perform them and make sure you get correct answers. Now, let's see. What is a solid of revolution? Now, the solid of revolution is a solid that is obtained by rotating a plane figure in a space about an x coplanar to the figure. So this is what we are trying to say is a solid of revolution. And I will show you in a short video shortly after that. Now, this is to say, for example, we have a function f of x, and this function of f of x is known as y, or sometimes it can be written vice versa to it. Some books can write like this, but it's still the same thing. So this is our function, and from this function we have the x-axis that bound this function, and then after that we have the value of the vertical line, let's say a vertical line that is x is equal to a, and also we have the vertical line another that is x is equal to b. And what am I talking about is something like this. We have xy plane, and remember this is y axis, and this also is the x axis. And let's say we have this is our function, and this function is so called y is equal to f of x. Now, we have the bound of this. As I said earlier, we have the this graph is bounded by the x-axis, and there is our x-axis. And also we have the vertical two vertical lines, and one of those is, let's say, that is x is equal to a, and we have another line, vertical one, that is x equal to b. Now, what will happen if you try to have that figure rotated about x-axis? That's why in a definition we've said the solid of revolution is a solid that is obtained. That means the solid that is left by rotating a plane figure. That means this is our plane figure. We are trying to rotate it about x-axis. That is why we have the definition like that. So we are going to find the volume of that solid of revolution from point A to point B. From point A to point B. Now consider the following. Consider you have a very small change. A very small change in x-axis. And this could form a rectangle, and that, let's say, is a small change of x. And that is the height of our rectangle. And this is, we can approximate it as a rectangle. And we can evaluate those strips. That is to say, we are going to evaluate the value of the width of that at this point in a small change of x. That means the value of x now, we are going to place it there. Let's say we are going to have f of x sub 1. Now, how are we going to find that volume of that rectangle as it is rotated about x-axis? As it is rotated about x-axis. We know that the formula to find the volume of something like that is pi r square times h. And remember, our dx, the small change in x, that is our height I'm trying to talk about. And our radius will be the f of x1. That means this will be your radius. This will be your radius. Now you will have the following. That is to say, you have the pi, and you will multiply with that. That is your radius. That is f of x1. That is squared times what? Times the small change in x. That will be dx. This will be the volume. Now remember, this is just one strip. These are called strips. This is just one strip. That small rectangle is called a strip. This is just one strip. Now we have to sum the strips from there. That try to assume that this place is divided into small strips. That means you have to sum the strips from, let's say, if we call the strips is I, the first one up to the last one, that you can say I equals to n. And that means in order for you to have the sum of that volume of revolution, you are going to sum the following: the first strip, the second one, the third one, up to n, That will be the following. Will be the summation from I is equal to 1 to n. That means n will denote your last strip of what? Of the volume of each and every strip that you are going to have. That is to say, we have a pi, then a pi multiplied by f of xi, because I will be changing, as you know, will be the values of x, and that will denote different types, different values of the height as we go on. This will be squared, and this will be multiplied. All of those will be multiplied by d of x. Now, we know that pi comes out of sigma notation, as we did in the last session. So we have the pi, we know that pi is a constant, times what? The sigma notation to that point, and then we have f of xi, and all of that is squared raised to x. Now, if we try to add those, it's the same as saying we are trying to add from x is equal to a to x is equal to b. And that is to say, the volume of that, by the use of integration methods, we know that the volume now will be equal to what? If you try to find the summation of those points, that means it will be the integral from point A to point B times pi of what? In brackets is f of x squared dx. So this will be the formula that will be used to find the volume of solid of revolution from point A to point B if the function is f of x and with respect to d of x. This will be the formula that we'll be using. Okay, now as I've said earlier that I can show you the video. Now we have the function that is y is equal to the under root of x. Now this graph, we shall bind this by two functions, and that one will be the first one, and the second one will be this one that will be shown shortly. Now we have that graph that is y is equal to 1 of 10 of x, that is our graph, and then after that we have the x that binds that volume there. So we have f4, and you can see the shaded area there is the volume I'm trying to talk, and you can see it rotates. As we rotate that, that means we are trying to have the f of x in different positions. But as you can understand, we cannot find the volume as it is all. That means we are trying to, we are going to try to divide it into very small strips, and then after that I will show you how it will look like. Now let's see. As you can see, we have taken one of the strips, and that is the small change I was talking about. That is a d of x. And then after that, we shall have the radius. As you can see there, from the point inside up the circumference is the f of x I'm trying to talk. That means you will have those two. That means that f of x is evaluated when we have the small change of x, that was d of x. That is to say, after that, we sum from the first point of the strip up to the last point. That means from the first limit to the last limit. That is a to b, and that will be your volume of devolution. Now let's see the few examples on how we can find the volume of solid of revolution. Now let's check example number 1. And we have the example number 1 that says, find the volume of solid of revolution in the first quadrant That means in this question, it's very, very easy. You have been told it is in first quadrant. As you know, we have 4 quadrants. And then this one is in first quadrant. And it's bounded by the graph that is f of x is equal to 4 minus x squared. And the coordinates axis, that means the coordinate axis from x-axis and y-axis, by rotating it about, first case, it will be rotated in x-axis, and the second case, it will be rotated in y-axis. Now, I will show you the sketch on how that will look like. Then, you will find how it is very, very easy to do. But before showing the sketch, how do we get that sketch? Let's see how do we get that sketch. Our function is f of x equals to 4 minus x squared. We know when we are trying to sketch, first of all, we have to find the x-intercepts and the y-intercepts. And how do we do that? Now we find the x-intercept when we can say when x is equal to 0. That is to say you are going to find the y-intercept. Then y equals to what? Our x equal to 0. That is x equals to 0 equals to what? Then it will be a 4 minus a 0, that is y will be equal to 4. That means our y-intercept is 4. Now, when y equals to 0, that means this part equals to 0, then we are going to have a 4 minus x squared equals to 0. It implies actually. Now, let's find the value of x. That means it will have x squared equals to negative 4. That is x squared equals to 4. That means x equals to plus or minus 2. Plus or minus 2. That means we have 2 x-intercepts. We have 2 x-intercepts. We have the negative one and then we have the positive one. Now, if we try to sketch that very easy, I will show you the sketch. We have, this is our y-axis. And this is our x-axis. Now, our x-intercept, we have a negative 2 and a positive 2. That means we have a negative 2 there and a positive 2. But also we have a y-intercept that is 4. That means it's somewhere there. This is just a sketch. I will show you the graph. That is to say, the graph turns like that. It's just a sketch, actually. I will show you how the graph looks like. Now, this is how it will look like. And that is to say, in our question, we have been told to find when it is rotated in the x-axis, and then after that we shall find when it is rotated about y-axis. Now let's see the graph. Now this is how the graph will look like. This is how the graph will look like as a way of obtained there, but also I obtained that and put it for you. Now this is rotated around x-axis. This is just the first case. And that is to say we have the small change in x, and then after that we shall have the function evaluated at that point, and then after that we shall find the volume of revolution. But remember, the question said the function f of x is equal to 4 minus x squared. And the coordinate, that means this binds this function. That is to say we are trying to look for the volume of revolution of this part here. Not the other part, just this part. That is to say, that's what we are going to look for. Now let's see. We have a very small change. Now this is our graph, that is f of x equals to 4 minus x squared. And this is the very small change I was talking about. Now this is your dx, that is your dx, and this is your function. This is your function. And then you are going to evaluate from 0, because the area that you have been told is in the first quadrant. And this is the first quadrant, the second one, the third one, as you know, the third one, and that is the fourth. So let's see, how will it look like? We know that the volume is found by the following formula. That is pi, and then the integral of what? of f of x, all of that is squared with respect to x from a to b. That's what we're trying to look for. That is to say, our limits now, our a will be a 0 and our b will be 2. Now let's see. We have pi from 0 to 2. Then the function. What is the function? The function is 4 minus x squared. So we have 4 minus x squared, and all of that, according to the formula, is squared. Then to that. This is very, very easy for you. So let's do it. So we have a pi, and then if we try to expand that from 0 to 2, that will be 16. Then this times that is 4x times 2 is 8x squared. Then this one repeats itself. That means it will be plus x raised to 4, and that is raised to times that thing. Then let's try to integrate that. It will be a pi, then a 16x minus, it will be 8x raised to 3 over 3 plus x raised to 5 over 5, and all of this is from 0 to 2. Now let's evaluate that. Now placing the values of x, we have a pi, there we have a 16 times 2 minus 8 over 3, 2 raised to 3, plus there is 2 raised to 5 over 5. Now you have to evaluate that. We are supposed to subtract with when this is multiplied by the whole, when 0 is placed there and when 0 is placed there. But we know that this will be 0. That's why I've just leave it somewhere there. That is to say, pi, this will be 32 minus, this is 8, and 2 raised to 3 is 8, and that is 64 over 3 plus, that will be 32, 2 raised to 5 is 32 over 5. And then the answer that you will obtain from this part will be the volume of revolution. Now let's check it by the use of our calculator and practice the good use of calculators. Now we have 32 minus 64 over 3, then plus 32 over 5. The answer I have obtained is, the volume could be, I have 17 1 over 15, that is pi cubic units. Don't forget to write like that, cubic units, because this is the volume. So we expect the units to be cubed. We expect the unit to be cubed. Now that is how we find the volume of a revolution if it is rotated about x-axis. What if it is rotated about y-axis? Let's check it. Now we did find the volume when the graph or when the function was rotated around x-axis. What will happen if we rotate the function around y-axis? Now let's see. This was our sketch of that graph, and let's see. Now if we rotate our sketch around the y-axis, that means it's rotating that way. At the first time, it was rotating around x-axis. By now, it is rotating around y-axis. That is to say, our small change will be in that. That means we are going to have our small change, that is dy, and our that is our height, and that is to say our radius will be x. That is the function evaluated in that form. That is to say, let's have that y equals to 4 minus x squared, we want to have the function in that form. That is, we can make the subject of x, that is going to be x squared equals to 4 minus y. And then we have x equals to the under root of 4 minus y. Because we have to evaluate that thing there. It will be like that. Now, remember, when we were looking for the intercepts, that was a 0, we know the origin, up to that point. That is to say, our volume of revolution now will be found by the formula we know it, the integral from a to b of the function squared. But our function now is in terms of y. So how will it look like? It will be the volume equals to pi from 0 to 4, and our function now is this one. So it is 4 minus y, 4 minus y, all of that is under root. And that is, now we don't have no more dx, but we have a dy. That will be the change in dy. But remember, that is a square. Don't forget that. Now we have to evaluate that. And how will it look like? Let's check it. So up to that point, and then this will be a 4 minus y. If you try to square that, that means the under root and 2 will go. That is, we are left with dy. I know you know how to change the limits, and then we were summing from 0 to 2. Now we are summing from 0 to 4. That means the strips are divided that way. At that time, the strips were divided that way. Now let's see. If you try to integrate that, it's a pi. Inside the bracket, it will be a 4y minus y squared over 2 from 0 to 4. And how will it look like again? It will be a pi 4, then times 4 minus y squared, that is 4, that is squared, over 2. That is to say, we have pi 16, and then there is 16 divided by 2, it's 8. And if you try to subtract that, it will be 8 pi cubic units. That is the volume when that sketch, or when that graph, or when that function is rotated around the y-axis, and the limits will be from 0 to 4. So that is how we look like. Now let's see the next example. As the example says, using the method of solid of revolution, prove that the volume of a sphere is of the sphere of radius r is 4 over 3 pi r cubic. Now consider the following. Consider you have something like that, and you have a sphere that is in the first quadrant. Let's say this is a part of a sphere, because we know a sphere can be divided into 4 quadrants, but let's have something like that, and then we shall rotate this to form a hemisphere, and then after that we shall multiply that hemisphere by 2 so that we can have the whole sphere. Now let's consider that we have something like that in the first quadrant, and let's say we have that has a radius r, as we have been told, and that radius r, and this point, let's say, is x comma y. That means this is y axis, and that is x axis, and that is the first quadrant. And what do we have again here? We have, if we try to look that much careful, that distance there is x, and that distance there is y. So by Pythagoras theorem, we can say r squared equals to what? Equals to x squared plus y squared. So our r could be what? let's try to use the function as in y square will be equal to what? R square minus x square. So our function will be like this: R square minus x square, and all of that is in under root form. So that will be our function. That will be our function. Now, what is our small change in something like that? Let's have a small change there. That will be a small change in x, and that will be f of x. So we'll evaluate at that point, and then this will be. And what will be our limits? And what will be our limit? Our limit will be, as we know, the distance from that point to that point is equal to x. But this is a radius because it is a circle. Because it is so that means it's a radius. That means our limits will be from 0 to r. Our limits will be from 0 to r. Now let's check it out. We know that the volume of solid of revolution is found by this formula from A to B. F of x, all of that is squared dx. That is to say pi. And we shall start from 0 to r, and our function is that one. So we have the under root of r square and as x square, and all of that is squared to x. So that is how it will look like. Now let's see. It will be a pi from 0 to r. If you try to do that, it will be r square x square. That is with respect to x. Now let's check it out. Let's try to manipulate that. How will it look like? It will be a pi. That will be r square x. If you try to integrate that, will be and then minus x raised to 3 over 3, something like that. And these limits will be from 0 to r. And now let's plug those. It will be a pi. It will be a pi over what? If you plug it there, it will be r raised to 3 minus r raised to 3 over 3. If you put a 0, then it will be a 0 to the whole expression. Now let's see. It will be a pi. If you try to subtract that, I do hope this multiplied by that point, it will be a 2r cubed. 2r cubed over 3. That is to say, the volume now will be 2 over 3 pi r cubed. Now, this volume we've obtained, as we know that, is the volume of the hemisphere. The volume, as we know, it will be the volume of the hemisphere. Now we want the volume of the whole sphere. Now the volume of the whole sphere, that means this must be multiplied by 2. And how do we do that? Let's multiply that by 2. So we have the volume 2. So we have 2 over 3 pi r cubed. That is to say we have a 4 over 3 pi r cubed. That is the volume, and that is how we show the question like that. We have been told by using the solid of revolution, prove that the volume of the sphere of radius r, and our sphere was that one of radius r, is 4 over 3 pi raised to 3. And we have used these steps, as I was explaining, to show that the volume is equal to that thing. Okay, now let's check the next example. Is example number 3, and find the volume of revolution formed when the area bound by the area. Remember that the area bound by the region x is equal to y square plus 3, and we have x is equal to minus or negative y square plus 5 is rotated through 2 pi. Is rotated through 2 pi radians about y axis. Just remember that. And then remember, it's rotated about 2 pi radians, that is 3/6, and that is the area. That means the area bounded by that. I know you have been doing how to find you have been doing on how to find the volume or the area between two caves. Between two caves. So we are going to rotate that area you've been looking for and see what will happen. And remember, from that point, you have to find the x-intercept, the y-intercept, and then sketch it. And then after you sketch it, you will see that where are we talking about and what already we are trying to talk about. I will show you the sketch. Now, this is the sketch. This is the sketch I'm trying to talk about, and I will show you how we are going to end up with such a sketch. And then after that, we shall find the area to that means this area is rotated 2 pi. That means it's rotated, let's say, along that line there in 360 degrees. That means it rotates 360 degrees. And the volume that we are going to look is that thing there. Now let's check it out and let's see how those two functions form that point there. Let's see it. So we have two functions. And our function is x equals to y square plus 3, and we have x equals to negative y square plus 5. Now let's find the limits. And how do we find the limits? And let's find the x-intercept and the y-intercept, and from there we can find the limits and whatever. Now let's see. These two equations are equal. That means we can equate and get the value of y. Let's check it out, and we shall have the following. We shall have y square plus 3 equals to negative y square plus 5. And that is to say, if we collect like terms, we are going to have the following. We are going to have a y square plus y square equals to what? Equals to this goes to that side, equals to 5 minus 3, that is 2y square equals to 2. Dividing that, we are going to have a 1, and then y equals to plus or minus, if you try to find the under root of that. So these are our points of intersections. These are the points of intersections. So if these are the points of intersections, and then you can find the y-intercept and x-intercept and try to sketch those graphs. These were the points of intersection. Now you can find the x-intercept, and let's say this is f1 and this is f2. That means this is function number 1 and that is function number 2. Let's find the x-intercept function number 1, and if there is y-intercept, and let's check it. How will it look like? Let's check it. So we have for function number 1, that is x equals to negative y square plus 5. What are we going to have? When x equals to 0, it implies that y square equals to 5, and then y equals to plus or minus 5. I think it's just plus or minus under root of 5, sorry. That means it's about 2 point something, because we know that 2 square is equal to 4. That means the under root of 5 is just 2 point something. That means we can sketch somewhere there. And let's have when y equals to 0, that is to say, we are going to put a 0 there, and then we have x equals to 5. That means this is the x-axis. This function number 1 will cut the x-axis at the point where x equals to 5. Now let's take the function number 2. That is x equals to y square plus 3. So when x equals to 0, that is to say y equals to what? Y equals to y square. Okay, when x equals to 0, what are we going to have? We are going to have a y square plus 3 equals to 0, then a y square equals to negative 3, and we know that this will be a complex number. That means y-intercept does not exist. Does not exist. What about x-intercept? Now when y equals to 0, what follows when y equals to 0? When y equals to 0, that means you are going to plug there 0, that is to say x equals to 3. That means we have x-intercept. We have x-intercept. And if you try to sketch that, you will end up having a graph like that. You end up, this was the 2 point I was talking about somewhere on the first graph, the 2 point on positive side and the negative side, and the x-intercept was 5, and I have obtained a 5 somewhere there. And we have the second graph that was that way. That was we didn't have the value of y-intercept. It was it doesn't exist, so it's not there, as you can see. And we have the value of x-intercept, that is 3. Now we have to find the volume that is formed between these two graphs. That means we have to find the volume of that minus the volume of that, the first graph minus the volume of the second graph. Then we subtract the 2, and then we have the function. Now let's see. But remember, our limits will be in y, that is to say in that form. So we know that the volume of revolution is found by that formula from A to B. But remember, in our example here, we have two functions. That means we have the first function and the second one. And we have seen from the sketch that in order to find the volume of that, we have to take the first minus the second one. And now let's see, we have, that means that is square, the first one, minus when the second one is squared, the second one, they're all squared, and then times dx, that will be the volume. Now let's check it. Let's do it. That means it's pi. Now our limits is from, as we have seen from the sketch, if you try to look that much careful, it will be from -1 to +1. And our graphs are in a very good form. That means we don't need to change anything. That will be -y square plus 5, this is squared, minus we have y square plus 3, and all of that is squared. But all of this will be integrated in respect to y, because our limits are in y, and our small change in y, as you can see there, is from -1 to 1. Let's check it. So be very careful there when you try to open those. So it will be the integral from -1 to 1. There we have a y raised to 4. And then what next? We have this and that, negative y times that is times 2 is 10y square plus 25 minus all of that will be y raised to 4 plus y, and that is a 60. If you take this and that, you multiply y square plus times 3 times 2, that is 6 plus 9. And remember, all of this will be integrated with respect to y. Let's use that part to do that mathematics. So we have a pi, this is volume, remember. So we have, let's collect like terms first, to 1. From -1 to 1, of what? This is -10 square, and that is -6 square. That means collecting those is -16, what? -16y square. And we have a +25 and a -9. Then collecting that is +16 with respect to y. And let's see, is pi, and we can take that 16 out so it can come out there. And then what are we going to be left with? We're going to be left with the that thing So this can be 1 minus y square with respect to y. That is 16 pi. Let's integrate that. It will be y minus y raised to 3 over 3 from negative 1 to 1. And let's try to find that. That means plugging these values there and that negative 1 and subtract. It will be 1 minus 1 over 3. If we try to put small brackets there, minus what? Negative 1 minus negative 1, but that is raised to 3 over 3. So be very, very careful, my dear student, on how you can manipulate those parts, because it is on those parts where you miss the answers. Now it is 16 pi. Then if you try to subtract that very careful there, it will be a 2 over 3 minus, let's simplify that. This will be negative and that will be, so it will be a negative 1 plus 1 over 3. And that means there will be a negative 2 over 3. And if negative and negative goes, that is to say we are going to have a 16 pi, then 4 over 3. That means our answer will be 64, 16 times 4 over 3. This will be cubic units. So this is how we find the volume of the evolution that is found, that is bound by those two functions. Now let's see some few questions here that I'll be leaving for you. I'll be leaving you to calculate or to manipulate. For example, here we have the first one that it says obtain the integration by integration the formula for the right circular cone of radius r and height h, and consider the area enclosed by that is y is equal to h over r x and y is equal to h. So please try to find that and have that formula. And the second example says find the volume of solid of evolution. Actually, this second one is very simple. Of solid of evolution generated by rotating the curve y is equal to x square between y is equal to 0 and y is equal to 4 about the x-axis. So the second one is very, very simple. Even the first one is very simple, but it needs you to think a little bit more. The third one says find the volume of solid of evolution generated by the solid of evolution for the region in the first quadrant bounded by the graph of y is equal to the cube root of x, the x-axis. And now here the limits were stated and the function was stated. Y is equal to cube root of x, the x-axis, and the line x is equal to 8. So please remember those, and those are the very basic hints for you to do. And this is rotated about what? First, it's rotated about x-axis, and the second time is rotated around in the line x is equal to 8. So these are very few questions, very, very few questions. There are a lot of questions, as I always say. There are a lot of questions, not only this. So please find those questions and do them, and I assure you, you'll have very good performance. Now, my dear students, I will leave you there today. I do hope you have made a lot of revisions as I was explaining this subtopic. So please keep on practicing, as you know you are still students. As I always say, please over please, behave, and I assure you, you will succeed in your life. Bye-bye.